All right, so our last chapter is chapter 11, and we'll be talking about different ways to solve quadratic equations. So first thing I want to do is review what we've already seen on quadratic equations. So we recall, first of all, just what the definition of a quadratic equation is. So a quadratic equation is an equation of the form ax squared plus bx plus c equals 0. And we have to say that a cannot equal 0 because if a was 0, we wouldn't have this term here, and it would just be linear. So a cannot equal 0, and this is what we call the standard form for a quadratic equation, because it could be kind of rearranged. The b, x, and the c could be on the right. It could be factored. So this is the standard form if everything is multiplied out and it's in descending order. And so what we've learned so far is the zero factor property. And so this is what we learned back in chapter 6 in Math 95. And so you might not remember it by name, but we have used it in this class. And so what this says is if a times b is equal to 0, then a equals 0 or b equals 0. So this is what we did when we kind of split our equation up into two separate equations. So what I want to do is start by solving just a couple of examples just as a refresher, and then we'll jump into kind of the main part of this section where we talk about the square root property. All right, so for these, we're told to solve, and you might be told to just solve the equation, and then you kind of want to figure out, should I factor? Should we use the should we use the square root property, which we'll get to? Sometimes you'll be told to use specifically the zero factor property or the square root property. So you will see some like those in your homework. For these, we're just told to solve, and in general, you should always try to factor first, because a lot of the times it's going to be the easiest, fastest thing to do. So first one here, we're given x squared minus 2x minus 15 equals 0. So first thing you want to do is make sure it's in standard form and equal to 0, which it is. So let's go ahead and factor. And if you remember, I like to use the big X for factoring these, whichever you want though. Just make sure that you're finding two numbers that multiply to negative 15 and add up to negative 2. That's going to give us, so I need a positive and a negative. We're going to have a 5 and 3, and the 5 has to be the negative to get that 2, negative 2. So let's factor this into x minus 5 times x plus 3 equals 0. And so this is where that zero factor property comes into play, because this is saying we have two things that are being multiplied and equal to 0. Well, in order to end up with 0 when you're multiplying two things together, either the first thing has to equal 0, so x minus 5 equals 0, or x plus 3 has to equal 0. So let's solve both of these. We'll add the 5 and we get x equals 5. And then here, if we subtract the 3, we get x equals negative 3. And then I'm going to go ahead and box both of these because these are our two final solutions here. All right, so in general, when you have an x squared or a quadratic equation, you should get two solutions. There are some cases where you just get one, and that's still possible with these different methods, but most of the time you will have as many solutions as your highest exponent. So if we had an x cubed, we could have up to 3 solutions. All right, let's go ahead and try a couple more of these. And just going back here, my math lab homework assignment for this will probably want you to write your answers as a solution set. So you would just have it written as 5, negative 3. So this is as a solution set. All right, now let's go ahead and try number 2. Number 2 here, we're given 2x squared minus 3x plus 1 equals 0. So again, same thing, let's try to factor first. So 3 terms, I'm going to use the big X. And this time, because we have a number in front of the x squared, we have to multiply these. So 2 times 1 is 2, still adding up to a negative 3. Well, if we're multiplying to a positive, adding to a negative, we need 2 negatives, and it has to be a 1 and a 2. So remember, when you have a number in front of the x squared, you cannot go straight to parentheses. Let's go ahead and split the middle term. So we get a 2x squared. Now, it doesn't matter what order these go in, they're both negative. So let's go ahead and I'll just do minus x minus 2x, and then plus 1 equals 0. Now, if we go ahead and group the first 2 terms, and now with these last 2 terms, I'm going to try making this a little bit smaller here. So that was a negative 2x. So what I'm going to do is I'm going to put a plus sign and then my parenthesis and leave that negative with the 2. That way you don't kind of mess up with the negatives there. Okay, now let's go ahead and factor out from each. So if we factor out from this first group here, we can take out an x. So we're left with a 2x. And then don't forget this one, minus 1. You can always double check by distributing again. Now, with this next group here, there isn't anything that they have in common besides a 1. But the big thing to keep in mind here is because we start with a negative, take out a negative. So I'll take out a negative 1. So I'm just going to change the signs of both of these so they become 2x minus 1 equals 0. And now let's factor out that 2x minus 1. And we're left with x minus 1. Now we are completely factored, and we can go ahead and split up our equation. So we get 2x minus 1 equals 0, or x minus 1 equals 0. Solving each one of these, we get 2x equals 1, divide by 2, and we get x equals 1/2. And this other one, we're going to add the 1, and we get x equals 1. All right, so again, we got 2 solutions. You could always take these, plug them back in, and check them that way. Unlike the radical equations we solved back in 10.6, you don't have to check these. You don't end up with extra solutions, but I always recommend checking your answers, especially on an exam. All right, so let's go ahead and try one last one. And this is going to kind of lead us into our square root property. So for this one, we're given x squared equals 4. And this is actually going to look exactly like something we'll be solving using the square root property. But using our 0 factor property, we want this equal to 0. So let's move this 4 over to the left. So we get x squared minus 4 equals 0. And if we factor this, this is the difference of squares. So to get x squared, we have x and x. To get 4, we have 2 and 2. We need a plus and a minus because it's negative 4. Now, if we split this up, we get x plus 2 equals 0 and x minus 2 equals 0. And if we go ahead and solve each one of these, we get x equals negative 2. And on the right here, we get x equals positive 2. So one way you can kind of combine these answers together, and this isn't how you'd write it on my math lab, but it's going to show us how we're going to use our square root property. This is the same thing as saying x is equal to plus and minus 2. This just means positive 2 and negative 2. So keeping that in mind, I'm going to write out the square root property, and then we'll come back to this one to kind of explain why we're doing what we're doing. So in general, we're going to have these other methods because we can't always factor. Factoring isn't always possible. If it was, we would just do factoring all the time. But this is why we have other methods. And one of them, which you might remember, is called the quadratic formula. We'll see that at the end. That'll be 11.2, I believe, or 11.3. So that's something we'll see in 11.3, and that's just kind of something that always works, no matter what you're given, as long as it's in standard form. Square root property that I'll write down now is going to work in certain cases, and so we'll see what those certain cases are. It's kind of like using the zero factor property. It's only, you can only use it when you have something that can be factored. This is only going to be used when you have something of this form. So if we're given x squared equals a, so this x squared could just be an x squared. You might also see something like this, where you have some group being squared, but you won't have any other variable terms besides what's in that group. So let me finish writing out the property, then we'll talk about it. So if we're given x squared equals a, then x is equal to plus or minus, so positive and negative, the square root of a. Now, how did we go from here to here? Well, what we did was, if you remember, square roots and squares are opposites. So if we're given the square, or x squared equals a, to get rid of the square root here, to get rid of the exponent, we take the square root. And if we do it to the right side, we just get the square root of a. One thing you have to do here is put plus or minus in front. This is something you always have to do, because if we go back here, if we applied the square root property to x squared equals 4, and I took the square root of both sides, these guys cancel. We get x equals the square root of 4, which is 2. But like we've seen, the solution to this problem is positive and negative 2, because if we square a negative 2, we also get 4. That's why you have to include plus and minus on the right. You don't do it on the left. So this is with the square root property. So you'll see you can solve these with the square root property. Sometimes you can also solve it with factoring. So let's go ahead and look at some examples. So examples, and we're told to solve using the square root property. So again, sometimes it'll say solve using the square root property. Sometimes it'll just say solve, so you're going to want to know which method to use. All right, so number 1 here, we're given x squared equals 49. Now, we could get this equal to 0, factor, and solve it that way. If we go ahead and use the square root property, the x squared is on the left, the number's on the right. So because we don't have any other terms except for the squared term and some number, you only want a number on the right, you don't want any variables, then we can use our square root property. You also want to make sure that the squared term is by itself. So you're going to get the squared term alone. And I'm going to say the squared term because it's not necessarily always an x. Could be like an x minus 4 squared, like I was talking about. But get the squared term alone first. And then this one, we already have the squared term alone. So we're going to go ahead and square root both sides. Always make sure you have the plus and the minus on the right. So you can either put it here, you can kind of put it in with the square root if you have room. I didn't leave enough room there. But on the left side, these cancel, we just get x. And on the right, the square root of 49 is 7. So our solution here as a solution set is positive 7 and negative 7. Let's do number 2. This next one we're given 3. Oh, which one do I want to do first? I'm going to switch the order here. Okay, so 3x squared minus 8 equals 88. For this one, we want to make sure that our squared term is alone. And so for this one, first thing we want to do is add this 8 to both sides. So we get 3x squared equals 96. And now one thing to be careful with here is what is being squared. And so in this case, there are no parentheses. If we had parentheses right here, then the squared term is alone. But because there are no parentheses, the only thing being squared is this x. So I'm going to go ahead and divide both sides by 3. So we get x squared equals 32. Now we can go ahead and square root because the x squared is alone. So let's square root. Now I'm going to go ahead and leave this as the square root of 32 for right now, because what we can go ahead and do is simplify this down. So this is why we had to learn all about simplifying radicals, because we're going to be using it here. So if we go ahead and break the square root of 32 down, I'm going to leave the plus and the minus in the front. 32 can be broken into 16 times 2. And so if we go ahead and take out the square root of 16, this plus and minus is going to stay in the front, and any number you take out has to go right next to the radical. So the square root of 16 is 4, so plus or minus 4 square root of 2. Now, to write this as a solution set, we have positive 4 square root of 2 and negative 4 square root of 2. Now you'll notice in both of these so far, we have just positive and negative of the same number. That will occur some of the time, but not all of the time. So let's go ahead and look at one more, and then we'll see when that doesn't happen. Number 3, we are given 3x squared minus 16 equals 0. So again, we want to get our x squared alone first. Let's get this x squared alone by adding the 16. So we get 3x squared equals 16. The x is the only thing being squared, so let's divide both sides by 3. We get x squared equals. Now, this doesn't go in evenly and we can't reduce it, so you're going to leave it as 16 over 3. And when we go ahead and square root both sides, we're going to square root the entire fraction. So when we simplify this down, we're going to have plus or minus. Now the square root of 16 is 4, so we can put that up there, but we cannot take the square root of 3. So we'll leave that down there. But now if you remember, we do not like to have square roots in the denominator. We want to go ahead and rationalize. And if you remember, when we rationalize, we multiply by the radical that's in the denominator. And so if we multiply by the square root of 3 over the square root of 3, then we're still going to have plus or minus in the front. On the top, we have 4 square root of 3. And if you remember the shortcut here, the square root of 3 times the square root of 3 is 3. This is our final solution. So as a solution set, we're going to have positive 4 square root of 3. So let me write this a little bit smaller. Positive 4 square root of 3 over 3. And negative 4 square root of 3 over 3. All right, so a big thing for that one is make sure you're rationalizing. Doesn't come up a whole lot, but make sure that if it does, you do it. Okay, let's go ahead and try another one. Number 4, we're given in parentheses x minus 4 squared equals 9. Now, this is one where instead of having just an x squared, we have an entire quantity being squared. So we want to go ahead and make sure that quantity being squared is alone, which it is. So we can go ahead and square root both sides. I'll put the plus or minus down here on the right. Now, when these cancel out, you're left with the group of terms on the inside. So you're left with an x minus 4. And then the square root of 9 is 3, so plus or minus 3. Now, you want to make sure that you solve for x at the end. So if we go ahead and add this 4 to both sides, a couple ways you can do this. We could write this as plus or minus 3 plus 4, or do it the way that I normally do it. So let me erase this one. Actually, I'll write them next to each other so you can see both. Or you can put the 4 in the front and then plus or minus 3. Now, I like doing it the second way because I think it looks a little bit more self-explanatory for what we're going to do next. Because our next step here is to split this up, and we're going to get 2 distinct answers here. So if we look at this first one, we have a positive 3 plus 4. And then our other solution is going to be negative 3 plus 4. So these are our 2 solutions, not simplified yet. So let's go ahead and simplify those down. 3 plus 4 is 7. Negative 3 plus 4 is 1. That's one way of doing it. Or if you wanted to do it this way, this looks a little bit nicer in my opinion. On the top, we have 4 plus 3. And on the bottom, we have 4 minus 3. Either way, we end up with 7 and 1. So whichever one you like better, I would stick to it. I'm going to be doing the second way where you put the number that you're moving over in the front. All right, so let's take a look at another example that looks kind of like that one. So number 5. Number 5, we're given 2x minus 5 squared equals 18. Now, again, make sure the term that's being squared is alone, which it is. We have 2x minus 5 squared equals 18. So if we go ahead and square root both sides, I'll put the plus or the minus here. I like to do it first so that you don't forget it. It's one of those little things that's kind of easy to forget. So this cancels. We're left with the 2x minus 5. Notice how we're never square rooting what's on the inside, keeping that alone. And now square root of 18 is something I'm going to be able to simplify down. So you can do it now or you can do it later. I like to get the simplifying just kind of done. So what we can do is we can break this 18 into a 9 times 2. I'm just kind of bringing down the left side of the equation here. Now leave the plus or minus, and square root of 9 is 3. So we have positive and negative 3 square root of 2. But we want to make sure that our x is alone. So first thing we'll do is, like a regular equation, add the 5. So again, what I'll do is I'll put the 5 in the front. So positive 5 plus or minus 3 square root of 2. And now our last step is to divide both sides by 2. So if we go ahead and do that, you can leave it just like this, or you can break it up. So I'll show you both ways. We get x equals 5 plus or minus 3 square root of 2 all over 2. And so if you write it like this, our solution set, let me write this down below. Our solution set is 5 plus 3 square root of 2 over 2. and 5 minus 3 square root of 2 over 2. This is one way to write your answer. The other way is to split this up. So by doing that, we would get 5 over 2 plus or minus 3 root 2 over 2. And this is kind of the preferred way of writing your answers because we like to have two distinct terms here. And so this solution set would be 5 over 2 plus 3 root 2 over 2, and then 5 over 2 minus 3 root 2 over 2. But again, my math lab shouldn't be picky with how you write this one in. So normally what I'll do is I'll just leave it combined into one fraction. All right, let's try another. So this one we're given 5x plus 1 squared minus 7 equals 0. So this is another one where, first of all, if we were trying to figure out which method to use, if we were going to try factoring this and using the zero factor property, we would have to square this first group here, combine like terms, and then refactor. This one is one of the ones that's nice to use the square root property with because we have something being squared and our only other term is unnumbered. So that's kind of the thinking process behind why we're using the square root property for these. Okay, so first thing we want to do is get the squared term by itself. So let's add 7 to both sides. So we get 5x plus 1 squared equals 7. Now we can square root both sides. So on the left side here, we get 5x plus 1. And on the right, square root of 7 cannot be simplified. So we'll leave it just as the square root of 7. Now let's go ahead and move our remaining coefficients and numbers on the left over to the right to solve for x. So let's subtract 1. And again, what I'm going to do is I'm going to leave that -1 in the front. And then we'll have plus or minus the square root of 7. And then I'll go ahead and divide both sides by 5. And again, I'm going to put the entire side over 5. So we get x equals -1 plus or minus the square root of 7 over 5. So our solution set is -1 plus the square root of 7 over 5 and -1 minus the square root of 7 over 5. Okay, now 2 last examples I want to show you guys before we take a look at some quick questions at the end. Let's do a new page. So number 7, we're given x squared equals -17. Now, one thing you should notice here is that we have an x squared equal to a negative. That isn't possible in the real number system, but remember we just talked about the imaginary numbers. And so this indicates that we're going to have an imaginary answer. So our x squared is by itself, so let's go ahead and square root both sides. I'm going to put a plus and minus on the right. So we get x equals, now the square root of -17, we can't take the square root of 17, but remember the square root of a negative is I. So I'm going to leave the plus and minus, bring out the I, and then we're left with that 17. Always make sure you simplify down your negatives inside a radical. Always take them out as an I. So our solution set here is positive I square root of 17 and negative I square root of 17. So let's try one more like that. So number 8, we're given k plus 5 squared equals negative 100. Now, our squared term is by itself, so we can go straight to square rooting, plus or minus on the right. So these guys cancel and we get k plus 5 equals, now the square root of a negative is I, square root of 100 is 10. So I'm actually going to backtrack a little bit because we can take the square root of 100. I'll put that 10 first and then the I. So we have positive and negative 10I. And now let's subtract over the 5. And once again, I'm going to put that negative 5 in the front. And we have negative 5 plus or minus 10I. Now, if you remember, this was the form of the complex numbers that we saw back in 10.7. Real part goes first normally, and then the imaginary part. That's another reason why I like to put that number in the front. So we have negative 5 plus 10I. And then negative 5 minus 10I. Okay, so that is the square root property. The next set of examples, I'm actually going to set them up like a matching type problem. And so this is something you'll see in the homework where you're determining what type of solutions you're going to have without actually solving the problems. So we're going to say determine the type of solutions. So we're going to have 4 equations here. We have x squared equals 12. X squared equals 25 over 36. X squared equals negative 36. And x squared equals 25. And our 4 options over here, we're going to have 2 integer solutions. B is 2 rational solutions that are not integer. C, we're going to have no real number solutions. And finally, D is going to be 2 irrational solutions. All right, so first things first, let's review what each of these things means. Integer just means a whole number answer, and it can be positive or negative. So something like 1, 2, 3, or 0, -1, -2, so on. So those are integers. Rational that are not integers, they specify because all integers are also rational, would be something like a fraction, like 1/2, 3/4, something like that. Real number, so not a real number solution means imaginary. And try to remember when we have imaginary solutions with x squareds. Let me put these guys in parentheses. And then irrational is something that when you take the square root of a number that is not a perfect square. So something like the square root of 10, the square root of 50, something that's not a perfect square. So let's go ahead and look at these. We look at this first one here. Notice how all of the x squareds are already by themselves, so we would go straight to taking the square root. Well, if we had the square root of 12, That is not a perfect square, and so it's not going to be integer. It wouldn't be rational. It would have to be irrational because that is the type of solution we get when we square root something that is not a perfect square. So this first one should be D. The second one, we have x squared equals 25 over 36. Well, if we think about square rooting this, we would have a 5 over 6. That's a fraction. Fractions are rational solutions that aren't integers. So this would be B. So we've used B and D. Now we have A and C left. Number 3 here, we're given x squared equals a negative. Anytime you see x squared equals a negative, you should automatically think this is not real. So this is C. We would have imaginary solutions, which leaves A for this last one here. That's because x squared equals 25. 25 is a perfect square, so we would have 5 and negative 5, which are both integer. All right, so that's the bulk of what you're going to be seeing in 11.1. The only other thing is an application problem that you'll see at the end. And so I do want to show you guys the application problem because it's a little different than what you've seen before. So this one, you're told the area, maybe I should type this one out, it'd probably go better. Let me try doing that for this one. That way you guys don't have to read my terrible handwriting. Okay, so the area of a circle is given by, now this is the part where I'm going to have to write. So it's given by A equals pi r squared. So then we're told if the circle has an area of, now that's the only annoying part with typing is that I kind of have to switch back in between, or switch back from typing to writing with some of this math notation. 81 pi inches squared. Then we're told to find the area. Or sorry, find the radius. We're given the area. All right, so let's see. We're told that the area of a circle is given by pi r squared. And the circle that we're working with has an area of 81 pi inches squared. And we're told to find the radius. So our formula is A equals pi r squared. The area that we're given is 81 pi. Now we can take this and plug it in for A over here because that's our area. So we know 81 pi equals pi r squared. So think of this like one of our equations we've been working with. We want to get this r squared by itself. So first thing I'll do is divide by pi. Remember, pi is just a number. It's 3.14159. Keeps going forever. It's irrational. But it's nice that it cancels out on both sides. So we're left with 81 equals r squared. And now what are we going to do to both sides to get the r by itself? Well, we're going to square root both sides. Now, one thing to keep in mind here is that if I put plus or minus square root of 81 is 9 equals r, even though this is how we'd solve a regular equation, because we're looking at an application here, we're looking for a distance because we're looking for the radius. We can't have negative distance, and so we're going to ignore the negative answer, and we're just going to have positive 9. And then because it's the radius, it's the length, it's going to be in inches. So 9 inches is the radius. So just remember with applications, you might not take both of the answers that you normally would. All right, so that is the square root property. Next, we'll be looking at completing the square, which is something that is not fun to do, but it is something you'll see in 126 because they use it quite a bit in pre-calc. So that, and then we have the quadratic formula and some word problems, and we'll be done.